Number 4. How can the energy levels of the atom be determined by measuring the light emitted from an atom? All right. So, kind of describe that just a little bit in number 3. I'm going to get more specific here in number 4. When an atom loses energy, okay, which is the situation we talked about in number 3, it falls from a higher energy state to a lower energy state. Okay, that could be all the way to the ground state, or it could simply be a lower energy excited state. The frequency of the emitted light observed in an element's line emission spectrum may be measured. Right? That's something that you can actually measure. And in class, we actually use little handheld spectrographs to measure the wavelengths of light. And again, according to Z equals lambda nu, you can calculate from the wavelength, you can calculate the frequency. The energy of each transition is calculated using the equation E is equal to Planck's constant multiplied by frequency, right? H nu, where nu is the frequency of each of the lines in the element's line emission spectrum. From the analysis of these results, the energy levels of an atom of each element may be determined. And so what that means is, because we can measure frequency fairly easily, we can use E is equal to H nu to calculate the energy of each photon fairly easily. Now remember, the energy of a photon, right, when a photon is emitted, that photon is going to carry energy that is equal to the difference in energy levels between which it transitioned. Okay, so if the electron is transitioning from E3 down to E2, it's going to have an energy total that is equal to the difference in the energy of E1 and the energy of E2. If that photon moves from E3 down to E1, right, the ground state, more energy is going to be present in that photon because that was a larger transition. Remember, the energy in a transition, the energy released during a transition is equal to the energy difference between those two energy levels.